to expand, how to leverage Hadoop to expand data warehousing capabilities. Before we get started, I wanted to mention Data Gurus, which is if you go to this URL, you can sign up, and we'll make sure to invite you to future webinars or to hands-on labs, meetups, any other type of learning opportunities. So if you can take some time to sign up there, it will be great because we can keep you up to date with more learning opportunities. The other thing that I wanted to mention before we get started is we have a handout that's going to provide details on a couple of other webinars that we have scheduled this week. So from the GoToWebinar control panel, if you look under handouts, there's going to be a file there, a PDF that includes this information with the links to these two webinars. The first one is very focused on machine learning, and this one's tomorrow. And it's leveraging, or it's using Apache Spark to do text classification, text analytics. And then the next one, it will be on Thursday, and it's an introduction to Apache Spark. But it's also using our newest data scientist tool, which is a self-serve data science tool called Data Science Experience. So a couple of great opportunities, great learning opportunities for you. So if you can download the handout and register for them, it will be wonderful. So with that, I'm going to give control to our presenter so that he can get started with the topic at hand. Suresh?
Thank you, Anna. Okay, so I'm just trying to figure out how to go into this presenter mode here. Just bear with me. Okay, Anna, can you can you view my screen? If you can answer me back using chat. Okay. Thank you, Anna. Again, hello, welcome. My name is Suresh Matlapudi. I am a solution engineer with IBM Open Source Analytics Group. Today, we are going to talk about how to deal with rapid growth in an aging enterprise data warehouse. So the target audience for this talk are data professionals with more data warehousing background and some awareness or knowledge about Hadoop or big data related technologies. Also, I want to add that this is not a talk about replacing your existing data warehouse. Instead, it is about using Hadoop along with existing data warehouse. Right? So what are the main motivation reasons for doing this? The most common reason, we see in the market is to avoid expensive upgrades to existing infrastructure, right? Especially if you are close to your capacity threshold, you have a very rapid growth of data, right? You have an option to upgrade to the latest version of your RDBMS systems or EDW components, or you can take the route whatever we are going to discuss now. The second reason is your business requirements are changing, right? So you are dealing with a new type of requirements, new type of data types, like more semi-structured or unstructured data is coming into your system. Most of you know that, right? Your existing data warehouse, RDBMS-based existing data warehouse is not 100% fit for that, right? So the second reason is you may want to extend your EDW with additional capabilities of big data platform like a big data or Hadoop. So this is an entry-level talk, so I'm not going to go into in-depth discussion about Hadoop and its capabilities or use cases. Right? First, let's talk about enterprise data warehouse and Hadoop as platforms in separate, and then we will discuss about SQL and Hadoop, why it is important in the context of data warehousing offload, followed by actual offloading implementation patterns. So this is the typical architecture diagram for enterprise data warehouse. It should be very familiar landscape for most of you. The core components of this architecture include a data integration layer. This is your ETL tool, right? Either InfoSphere, or it's your Ab Initio, or it's your Informatica, right? Also, you have a data repository which is built on top of RDBMS like DB2, Oracle, or it could be an appliance like Netezza, right? Also, you may have on the data delivery side, you may have one or more BI tools for report generation. So there is no doubt that this model is good at what it is designed for. So that is powering the business analytics. Only the clean and consistent data gets into the system. That has a huge advantage in terms of how to provide a consistent response time. Right? Also, it is backed up by RDBMS system, so they have advanced workload management or query optimizations improved over many number of years. We can support multiple users. We can execute reports and queries concurrently with a more, as I told, with more consistent response time. So what are the limitations in this model? Right? Why we are talking about offloading some work to Hadoop at this time? Right? So some of the limitations are dealing with rapid data growth. It can be going upgrade route can be prohibitively expensive, right? Due to the cost to scale factor on EDW is actually not very advantageous. Also, as I mentioned, if you are dealing with more semi-structured data like JSON or unstructured data, it's not going to be easy, right? When I'm talking about unstructured data, you are dealing with data types like a block content or an email text or text documents or maybe user reviews, right? It's a free-form text, right? So this is RDBMS is not a place where you can store it, but retrieving it and analyzing it's difficult, right? Also, it follows in data warehouse we follow write. So what it means is it takes a longer cycle to get new data into the system before you can actually run any queries or analytics on top of the data. So those are the limitations, driving factors where we are talking about this offloading. On the other hand, Hadoop is an open source software framework for distributed data storage and also distributed data processing, right? So it includes a foundation components and also many tools built around this foundation to help us with data ingestion and data processing and data query. So let's see what are those foundation components. As you can see in this diagram, the bottom right hand side, Hadoop distributed file system, MapReduce, and YARN. So these three form the foundation of Hadoop, and many tools actually uses the capabilities of these foundations. So let's see what are those components. Right? For data ingestion, that is for getting data into Hadoop, we have Scoop and Flume. Scoop is for data exchange with RDBMS, and you can do both extract as well as loading data into the RDBMS systems from Hadoop, right? Whereas Flume is for continuous data collection. into the Hadoop. You can ingest data like application logs or streaming data also can be ingested continuously into Hadoop. Note that we're not calling this as a ETL. The main reason for that is, right, Hadoop takes a different approach. It takes a schema on read approach. You worry more about getting the raw data into the system as quick as possible, and right, worry about how to organize this data later. Right, so that is what is the schema on read approach. Right. So for data processing and querying side, very popular and common tools are included with most of the distributions are Pig and Hive. Pig is more suitable for building a long data processing pipelines using a language called Pig Latin, whereas Hive uses a SQL-like language called HQL. You can use Hive for both okay. Looks like I got reconnected. Anna, can you hear me?
Yes, I can hear you now.
Okay, can you tell? Not sure if it is only issue. Okay, so let me try to recap whatever I'm talking here. So you have Scoop and Flume for data ingestion, and we have Pig and Hive for data processing and data querying, right? What are the strengths of Hadoop? Most of you are, right, I'm sure, aware of this. It is actually good at dealing massive amounts of data, and also Hadoop is designed for linear scalability, and it has a better cost to scale factor compared to your enterprise data warehouse. Typically, your data warehouse cost model is based on number of CPUs. So that's where the not only the architectural limitations, even the cost-wise, it's not very optimal solution for upgrading. So when it comes to limitation, there are many areas where still it is a work in progress, especially around security, workload management, SQL language, compatibility, as well as features, right? Especially Hive, it is SQL-like language, but it's not a complete set of SQL, right? So don't expect your BI tools to work with Hadoop data out of the box, right? And also, if you are a ETL developers, you will be missing many features like your graphical user interface for developing ETL workflows. Also, there is no GUI for workflow management, and also data lineage, data profiling, and data quality. That's still a work in progress on Hadoop side. So let's talk about SQL and Hadoop. Right? Most of you know that Hadoop execution framework is MapReduce. It requires a Java API for application development. So in the beginning, that is how all the Hadoop developers started on their application development, right? But quickly found out that That's not a productive way of developing data applications. If you have to use the Java API and then compile it and then test it, right? So that is the main reason for tools like Pig and Hive. They become very popular. They allow us to use higher level languages or languages which we're familiar with. Right? So it's obvious that out of these tools, right, we need to leverage SQL to the maximum extent, as I mentioned earlier, right? Most of us, whether you're right, we are ETL developers or DBAs or BA report developers, everyone knows about SQL. So why not use it to the maximum extent? So there are no, as I mentioned, there are many tools around Hadoop ecosystem, especially SQL and Hadoop. There are this category is numerous number of offer, right? So they are different in their capabilities, right? In terms of SQL compatibility, the type of storage formats they support, integration with Hive Metastore. We'll talk more about what is Hive Metastore, why it is important to have a interoperability, and also the performance and right workload characteristics. I'm going to go over some of these tools. It's not going to be a complete list, and also I'm not going to do a comparison of capabilities between these tools, right? So to start with Apache Hive, this is the original SQL offering on Hadoop, HQL for querying, and it's good at dealing with batch workloads, right? The underlying execution engine for this is MapReduce in the beginning, but later, right, it can use a different execution engine called Tej for more faster retrieval of the data. Right? It keeps the information about tables and data sets in a store backed up by again a RDBMS, which is called Hive Metastore, right? So all the details about what are the available tables, what are their column structures, what are the storage formats backed up by underlying storage formats for the table, that is available in Hive Metastore. And also Hive Metastore over the years become a metadata layer for all the tools across the Hadoop, right? So it is important when you are evaluating a new tool, look for that interoperability with Hive Metastore. It not only gives a compatibility with Metastore, but also other tools can use the data created by your own tool, right? So that is the advantage. Impala is Cloudera's output to add interactive workload capabilities to Hadoop, right? So Hive is there with all the distributions, very popular, but it's still in batch mode, right? So that's where Cloudera decided, okay, we need more than batch capabilities, right? So Impala for that. It uses MPP architecture. It has Hive Metastore integration, a better SQL compliance compared to Hive. Also supports multiple Hadoop file formats. But based on the architecture of Impala, it's better to use a Parquet if you really want to get the performance benefit. The next one is BigSQL by IBM. Again, this is also a product with MPP architecture. Whenever you see SQL tools with MPP architecture, they are typically in interactive kind of, they're designed for interactive kind of workloads, right? Obviously, they can deal with the batch, but right, the more challenges comes into the picture when you deal with the interactive workloads, right? So there are a good number of MPP architecture-based products, right? So IBM SQL is one of it. We will talk more in details in my next section, next slides. Hawk is actually Pivotal's work. based on Pivotal's Greenplum and Progress Postgres SQL engine. It also uses MPP architecture. It has high standard SQL compliance, and it does, the only downside is, right, it doesn't use Hive Metastore yet. Presto is very interesting open source SQL and Hadoop project, like BigSQL and Hawk. It uses MPP architecture. Most of the other MPP architecture products, they are developed in C and C++ for performance, right? Whereas Presto is actually entirely developed in Java. Right? It's very popular among big shops like Facebook and Netflix. Some of the, you may not expect to see some of the enterprise features in Hive. I mean, sorry, in Presto. Right? Again, there is also Apache Drill trying to solve a similar problem and also add some other set of features like a schema on discovery. It doesn't use MapReduce execution engine. It uses its own execution engine called DrillBits. Right? The very popular Spark also has a module called Spark SQL. You cannot expect it to use it as a standalone offering, but if you are a Spark developer using Spark and SQL, probably right, gives you ability to mix SQL with your Spark code. So we did talk about, right, we did go through a list of SQL offerings on Hadoop. But in the context of EDW offload, okay, what you need to look for in SQL engines, right? What is important for us, right? So you need to ask some of the questions like, okay, how important the ANSI SQL compatibility is, right? So is Hive Metastore integration needed, right? Also, what are the supported storage formats? Does it provide SQL federation, right? We will see why SQL federation is also important, right? So based on my experience, so my recommendation is you can use more than one engine, depending on what you are doing. For example, for a typical EDW offload involves ETL workload as well as data delivery using your BI tools or querying, right? So for building data pipelines, when you take the Hadoop ingested data and preparing it for querying, right? That is your typical ETL work. You can just use Hive, right? So Hive is good at dealing with batch, you can build multiple Hive scripts to build that data pipeline, right? And also one thing to remember is you're not going to port any of your ETL code from data warehouse into the Hadoop. That's not simply right, productive. So you don't need to expect a full SQL compatibility in Hive, right? Especially you are using it for building data pipelines, right? Whereas on the other hand, if you are using an existing BI tool to report on top of data in Hadoop, you need more than Hive, right? So the workload is typically interactive. You need to support more number of queries which are generated by your BI tools, and also execute number of queries at the same time, and also you need to have at least a decent consistent response time, right, when these reports are executed by the users, right? The second factor is SQL compatibility. When you're dealing with BI reporting on top of Hadoop, you need to have a good SQL compatibility, right? Otherwise, you are going to refactor large number of reports, which is going to be very expensive. Some of these BI tools have a drivers to read data from Hive directly, but in my experience, it's not that easy task. Also, in enterprise environment, data security is also important. Typically, right, you need to have a role-based security. Support for the other aspect is support for open data formats in Hadoop, right? So what I mean by that is there are number of formats designed specifically for optimizing Hadoop data storage, like Parquet, Avro. You have optimized row columnar format, and also right your normal data formats like text, JSON, and CSV file. Right. This is important to avoid tool locking. Right. If the tool selected by you, if it is using its own proprietary format, you can use that your data only with that tool, or you will end up doing a costly data migration if you decide to switch to a different tool. Right? So let me give you more details about IBM's Big SQL. It is with MPP architecture, as I mentioned earlier. It has the best-in-class ANSI compliant SQL. I think Hawk and IBM Big SQL, they are the two products with better SQL features and compliance. Right? What that gives you is, right, you can write queries using standard SQL and also plug your favorite tools like Cognos and other BI tools, right? Reports will run just as expected. You don't have to refactor them, right? It also includes advanced cost-based optimizer. This is where the DB2 engine comes into the picture, and also some of the optimization features we got it from Netezza. They are actually infused with this tool in this tool. So it helps you with running the big ad hoc queries, right? The bigger the query gets, the optimization, you'll get more optimization benefits, right? And also one of the core feature missing in most of the SQL tools on Hadoop is the workload management, right? So it's not about executing a single big query and see how fast it runs, right? When you're using BI reports or the ad hoc querying, it's also about how many number of concurrent queries you can run, right? So for handling a better handling of concurrent queries requires a active workload management, right? Things like if you're running a big query, it should not stop users executing small queries in parallel, right? By taking up the entire cluster of resources, right? So that needs a better workload management, right? IBM Big SQL has one of the best workload managers out there. Also, you get the role-based security. The last important distinguisher is the federation capabilities. There are other tools supports the federation. IBM Big SQL Federation gives you ability to query data from stores outside Hadoop, right? So you can, for example, you can query the data from DB2, Oracle, or Netezza and merge the data with Hadoop, right? So this is important for offloading because we are storing the data in two different platforms now. One is your existing EDW on Hadoop, right? Depending on how are you organizing your data, having a federation capability is extremely helpful. Also, as I mentioned, Big SQL uses the standard open data file formats. It works with Hive Metastore seamlessly, so there is no lock-in there. It also supports Hive UDFs and all other Hive data types. So with that background, we talked a great deal about SQL offerings on Hadoop. So let's get back to offloading part. So one of the first question is, okay, what we want to offload, right? What type of workloads are suitable for offloading to Hadoop, right? So based on my experience, the easy ones we'll take top three of them, right, in the difficulty order. First, we'll start with the easiest one. The high volume infrequently used data, it can be offloaded to Hadoop, right? So you have the data, you need data warehouse, you're not using it that frequently, so it's expensive to keep the data in data warehouse. So let's move that to Hadoop, right? And also, it's not very uncommon to have just-in-case data, right? So this is the data where you don't see any immediate usage, but you cannot delete it, right? You need to keep it for various reasons, maybe a compliance reason, right? So that kind of data is actually optimal to store it on Hadoop. The second one is massive fact tables. This type of workload is better suitable on Hadoop side. So these are the tables with the data from, let's say, call center records, or you have ingested you have loaded any data from your event sources into data warehouse. It tends to grow very quicker. So these kind of fact tables, they are better suited on Hadoop side, right? Typically, you don't run too many reports on this. Also, there are certain number of queries going against it, right? So they can better run on Hadoop side, right? So we'll talk more about this. The third case is new type of data sources, right? Application log data, data from your web services or social media data. So this is typically high volume, semi-structured, unstructured. You may not be able to process them using ETL tools or store it on data warehouse inside. So this is better to move the data into Hadoop. Also, a traditional approach of modeling a relational table for this kind of data, it may not work. Right? So let's take a close look at each of these implementations, each of these workloads, and what are the suitable implementation patterns in details. So with that basics in place, right, you need to do some work in advance before putting your workloads into these different categories. So that information typically comes out of your regular capacity planning exercise, right? You gather information like, okay, what are the tables, right, suitable for this kind of offloading, right? What is their current data size? What are their growth projections? Importantly, right, what is their data usage pattern in BI reports, right? That is also an important factor. Also the target users, being that, right, who is using data in these tables, right? So you need to do some analysis on that in that area, and come up with a list of tables you are going to offload, and what patterns you are going to follow for each kind of workload, right? So let's talk about offloading cold data. As I told, this is probably the easiest one. There are many ways to do it, but rely on the existing skills, that is SQL, and keep the implementation simple. So the first step for this is you need to define required table schemas on Hadoop side using, you can use Hive Shell or Hive Client for that, right? And whenever you're dealing with data from external RDBMS systems, right, into Hadoop, use Scoop. Scoop is there for a long time. It is proven. It can scale to your data size. Right? So in this context, we just have to do a one-time migration of cold data into HDFS and repeat this cycle for new batches as data become cold. Right? And also, you need to make sure that if all the required reference data, right, also get the data right? So just having a fact table on Hadoop is not going to give you any query capabilities, right? You also need to have the required dimension data along with that. So at this stage, you can execute queries on Hadoop. You can use Hive SQL. There are many number of Hive clients are available. You can use it and query the data, right? Most of the times you are good with it because assuming that if you don't have any BI reports going against this cold data, you can leave it like that. You move the data to Hadoop, you have a query capability there. If you want to use it, you can go there and query it. If you want to get it back to Hadoop data warehouse, especially after aggregating, you can do it, right? If you have BI reports generating queries on top of this cold data, typically it is going to be aggregate data, right? So in that case, you can do that aggregations on Hadoop and load it back to EDW. The second workload we discussed about, right, offloading massive fact tables. You can do that in two different ways, right? So you can move the entire fact table to Hadoop, or you can move partial data to Hadoop, right? So first, let's talk about the entire table. Right? Again, you'll start with required table schemas and for fact as well as reference data on Hadoop side. On data ingestion side, it includes a one-time data migration from data warehouse to Hadoop. Also, a schedule data refresh cycle for reference data, right? So here for reference data, one thing, right, I want to share my experience is it is better to get that information from either your data warehouse or get it populated by your ETL tools instead of going against source systems, right? The main reason for that is typically your dimension data conditioning requires a lot of business logic. You don't want to repeat all those logics on Hadoop side, right? Instead of that, you can just focus on offloading of the fact tables, right? Also, the dimension data volume is typically low, so you can afford to get the data from data warehouse, which is already conditioned, right? Also, for an ongoing basis, the fact data, you need to get it from the source systems. All these steps you can handle with Scoop utility, right? So if your daily, let's say you have daily batches to ingest this fact table into Hadoop, once the data is ingested from source systems, you typically need to condition it, right? So you can use Hive scripts to build that condition logic, right? You may need more than one. You can actually link all those Hive scripts to achieve that data transformation needs. But when it comes to BI reporting, again, right, we need to do more, some more additional work, right? So this is, remember, this is not cold data. This is active data, right? It's just a big data, right? So we need to support more number of reports, more number of queries, and also more number of users, right? So this is where you experience the limitations of Hive. Again, right, Hive is good for batches, not so far for interactive workloads, right? So you will miss your consistent response times like from RDBMS, right? And also miss some certain, if you're trying to do it in Hive, typically for people from SQL background, miss some of the SQL constructs like subqueries, right? So this is where the other SQL engines comes into the picture. Having a tool like BigSQL definitely is going to help you, right, in this area, especially the data delivery and the BI reporting. If your BI reporting, BI reports require aggregated data, you can follow this similar pattern, whatever we discussed earlier. You can aggregate that data on Hadoop side, load it back to data warehouse. Again, it depends on what what is the volume of data, right, you are loading. Typically, after aggregation, your data should go down, right? Otherwise, if your BI tools need to work directly on Hadoop side, as I told, right, having a tool better suited for interactive workloads is definitely going to help you in terms of effort as well as the cost to get this project done. So let's talk about partial data upload. So all the in this so what I mean by partial data is, right, you're going to keep the latest data in data warehouse and move the older data into Hadoop, right? So typically Hive keeps the more data volume. Your data warehouse keeps the latest latest data, right? All the points discussed earlier, they are still relevant here. Except that you don't have to go against your source systems, right? You can do a one-time data migration of older data and move older data from EDW to Hadoop at required intervals. It could be monthly interval or quarterly interval. You can do it, right? In addition to some of the patterns discussed earlier, here your data is spread across multiple systems, right? So what are the options to do reporting on this kind of data model, right? If you look for query federation capabilities in SQL engine, BigSQL is one of it. You can use it to combine the data between EDW and Hadoop, right? And also the other way to do it is you can get entire data to Hadoop also. Your data warehouse keeps the latest data set, whereas Hadoop keeps the entire data, right? But you need to do some work on your BI tool side. You need to have some smart query routing depending on what type of data it is going against, right? So reports using only latest data sets, you can actually run them on data warehouse, point them to data warehouse. Whereas for reports using the entire data set from the table, you need to route them to Hadoop, right? That's another way to achieve this requirement, right? And also explore, some of the BI tools, they have a capability of supporting multi-source tables. That is the one thing you can also explore, but typically, right, if you're moving the data into BI tools, right, you need to consider, okay, what is the amount of data you are going to move into BI tools for merging, right? That factor you need to consider. The final workload type is, I call it as a new type data loads. This is more advanced compared to earlier workloads. Here we are dealing with non-relational data sources. They come, and they can be internal or external. Typically, as I told earlier, typically it's a structured or non-structured data, right? So we need to use some new tools other than Scoop and Hive. Typically, you can use Flume if the requirement is to move the data into Hadoop without any conditioning or transformation, right? So for example, you have a log collection service, right? You want to get the data into Flume. You want to get the data into Hadoop. You can assemble a Flume topology to do it, right? And you can do it without needing to code it. It's all configuration driven. You can do it, right? The other aspect you need to consider is, let's say if you're dealing with high volume streaming data and you have a requirement for stream processing, probably you need to look for tools like Apache, Spark, to achieve that, right? At this time, you are using real strengths of Hadoop compared to EDW, right? So this is what Hadoop is for, right? Now you have a capability to combine data from both internal and external data sources. You can deal with massive amounts of data, unstructured data, and you're not going to, while ingesting the data, right, you're not spending time on modeling a schema for it. You get the data into the HDFS in a raw format, and depending on your use cases and queries you need to run it, you can actually organize the data right, in a suitable format. That goes back to the schema on read approach we discussed earlier. So let's recap, right? In the beginning, we talked about what is EDW offload, what are the reasons for doing this. Then we talked about SQL and Hadoop and some of the available offerings. So finally, we briefly touched on IBM Big SQL, how Hadoop can be used for right, for doing this offload by complementing with the existing data warehouse, right? We talked about some of the hybrid architecture patterns depending on what we are offloading, right? I hope this information is useful, and thank you for listening. I'm handing it back to Anna.
Do we have any questions from the audience? Either raise your hand so I can unmute your line, or write a question on the chat window. Okay, I guess not. Thank you so much for joining us, and please remember to download the handout that's available with information about a couple more webinars that we have scheduled throughout this week. Thank you so much for attending.